Hello, class. This is the second structured communication that I have with you every week. It's where I introduce something new that's going on in the world of science, usually chemistry, and I usually get it from Chemical Engineering News. That's the magazine, it's monthly now, monthly magazine of the American Chemical Society, which is the biggest chemistry society in the world. And it's like if you are old enough to know what Reader's Digest is, it's kind of Reader's Digest of chemistry and science in general. So this is the week article that I had chosen. It's from back in June this year, so it's a little old. I mean, not too old, I guess. But I like this article because it kind of talks about what science is and how we do things and how we think about things. So I'm going to start a discussion with this, and it's optional for you guys to join. So if you want to have a discussion, it's up. I mean, this is optional for you. But let me go into the article, and I'm going to highlight some of the things about the article. I'm going to send you the article as well. And so this is a pink planet. So this planet is about 54 light years away, I think. 57. It says 57 light years away. And this is a star, and it's outside the orbit of Neptune relative to the star. And so obviously Neptune is a planet around our sun, around Sol in the solar system. And Sol is the official name of the sun. So, and using ground-based telescopes, they noticed that this is kind of a reddish hue. And then we use the James Webb Space Telescope. So the James Webb, it's an infrared telescope that's at the Lagrange 2 point. That's about 4 million miles away. And we looked at the Lagrange 2 point. We used the James Webb, and then James Webb could use more advanced techniques and could tell what the composition of the atmosphere of this planet was. And from that, we couldn't quite figure out why this planet was pink. And then some people did some models, ran some calculations, and then one of the ideas was maybe there's salty clouds. So there's clouds of salty salt, and so these models suggest, and I'm using the word suggest, that this planet is pink from these salty clouds. So now, why am I being careful with my words, saying the word suggest? Because data is although this article doesn't really kind of says, oh, it's salty clouds, this confirms it. In my opinion, this is not confirmed. That the theories provide, but experiments decide. So the observational data from the James Webb and the ground-based telescopes, that confirms, okay, the planet is pink. We know that. So why is it pink? We believe that it seems to be that it is from salty clouds. So although we might as well affirm that it's knowledge, but this knowledge is tentative. So 57 light years is very far away. So the Earth, for instance, is a little over 8 light minutes away from the sun, and that's 93 million miles. So a light year is a very long distance. So it would take light 57 years just to go there. We could verify it by taking a probe and going there, and then something like the Juno probe in Jupiter, we could go and analyze the composition of this atmosphere. And of course, if it beamed the data back, it would take another 57 years. And unless we had warp travel like Star Trek, right? But sorry, I know I'm a nerd. This is not directly verified. So models are great, and they work very well, but it's not real data. If someone asked me why this star is pink, or this planet is pink, I would say because of salty clouds. So, but what our knowledge is truly founded upon, is sometimes this is just it's shaky, and so much of we know, and at least we think we understand, is on this kind of level of shakiness. So, and it's even scarier when we think about things like the human body, and we do things that like take certain medications, for instance, based off of this shaky best guess knowledge. So it's kind of scary in a way. I always find it kind of scary, but to know what we know why we know it and how we know it and to what degree we know things. I mean, we're doing our best. I mean, we are doing our best, but we like what we know and how we know things is kind of can be on shaky ground. And so what is knowledge, like, at least in terms of this, like what does our knowledge mean? Hopefully this helps you understand that we have this knowledge and how we know things and how we can be absolutely wrong and we can believe we're right, but what are the consequences? And in some cases, though, I mean, the models fit. I mean, I know I usually try to keep this to 5 to 10 minutes. I know I'm going over, but like, for instance, the Earth, Wind, Fire, Water model of elements versus the periodic table. The Earth, Wind, Fire, Water model, it's a pretty good model, and you can accurately predict many things with that model. It's not perfect, though. So, the contemporary chemistry model, I mean, we're pretty sure that's right, though. I mean, it's not like you're going to say, well, it turns out the periodic table's wrong. No, that's right. We know. I mean, we can see atoms, so we have this more than verified beyond a reasonable doubt. So don't worry that you're like, oh, this is all wrong. Although there are some things that you learn that are kind of shaky. I mean, Lewis theory, for instance, that's wrong. When you're doing Lewis structures, that's not real. But we can talk about that later. Another thing is, notice it says ground-based telescope. So bringing it back here to our neighborhood in Hawaii, right? So astronomy has been a big thing in Hawaii because of the Big Island and because of the telescopes. And as of the recording of this video, the 30-meter telescope is, if we're going to build that, is still a question mark. The truth of the matter is, when the James Webb Space Telescope was launched into space, that was pretty much the end of Hawaii's dominance in the field of astronomy. So we're on the way of being obsolete. So and the problem with that is in terms of economics. So one thing about science is also very political, not just economic, it's not just for fun. There's economic and political consequences of things. So at the Big Island, for instance, it's been estimated to as high as a third of the economy of the Big Island is somewhat, shape or form tied to astronomy. So not just like the money from the astronomy, but it's the astronomers, and they come and they put their kids in school, for instance, and they buy food in the grocery stores, these kind of things. So as the ground-based telescopes become obsolete, and if we're not going to have the investment of the 30-meter telescope, that's going to be a big economic hit for the Big Island. And as astronomy has already started to leave Hawaii, what's going to happen in the economy of the Big Island, right? So, I mean, you see what happened in Molokai when the horse farm left. So that completely altered the economy of the island of Molokai. If you similarly, if you have such a huge aspect of the economy in the Big Island, what's going to happen when astronomy leaves? I mean, are people going to just accept and let their per capita income go down, and therefore also let the quality of services of the government go down? Are people going to do that? Or are they going to want to maintain or increase their per capita income and services from the government? So will people then say, okay, we need to start developing more hotels and and bring in more tourism to the Big Island? Are we going to start widening the roads to bring in to allow more commerce and flow of individuals to more areas of the Big Island for tourism? I mean, we'll see. I don't know. I mean, this is decades away, but it's interesting, and so you can see this is all tied in specifically to astronomy, to science, right? And there are political consequences of it. There's economic consequences of things, and I mean, they don't even mention the ground-based telescope. We don't know if it's Keck. That's the 10-meter telescope, Keck 1, Keck 2. They're twin telescopes of sorts on Mauna Kea, and we don't know if it's Arizona. We don't know if it's Canary Islands. We don't know if it's Gemini in Chile or something. There's other telescopes, right? So and they're not even noted. The only one that's noted here is the James Webb, because James Webb, that's the new cool thing. Oh, and speaking of which, there's a recent telescope just went up. So that was surprisingly not in the news. So, but okay, well, hope this has got you thinking about science. I mentioned a lot of things, a lot of topics we can talk about in discussion. So let's see where this goes. So also with all my messages, I mentioned before, I do see one of the roles of faculty is to be a triage of sorts for students, and I mean, also it's a dual responsibility, because if you are not well, if you're not getting food, if you're not getting shelter, if you're dealing with crippling mental health issues, you're not going to be performing at top. As one human being, I always say biological intelligence, because of all this artificial intelligence. There's one biological intelligence to the other. You know, we do require. We're not data centers. We don't just need water and electricity. We need lots of other things. So if those things are lacking, we need help. So if you find yourself in that predicament, so feel free to reach out to me, and I will do what I can to help you. So, okay, hopefully your brains feel stimulated, and I will say aloha for now. But I promise I won't talk as long as this one. So sometimes I get into a mood and talk forever. Sometimes I try to keep it short, because I know you guys have other things going on. So goodbye for now.